Hello, let me do some problems from projectile motion. I have several problems displayed here, and you will see that all of these problems involve very similar concepts. Again, if you recall, a projectile motion is something that that has no x acceleration, but only y acceleration, which is the acceleration due to gravity. So if you realize that, then you have two sets of equations, one for x and another for y. So any of these problems that you see here will involve a very similar technique. So for x, there is no acceleration, so the equation for final velocity Vx equal to V0x, okay, no change in velocity because there is no acceleration. The second equation is for the displacement, horizontal displacement, how much horizontal displacement you have, V0x times t. For y, they are the equations for free fall. So we can write Vy equal to V0y minus gt. The other equation is y minus y0 equal to V0yt minus 1/2 gt squared. And the last equation is Vy squared minus V0y squared equal to minus 2g y minus y0. So these are the equations that we will be using for all of these problems. Okay. If you go to the lecture video where I described 3 different types of motion, as I mentioned before, all of these problems will fall into 3 categories. One, that start from the ground level. So this is the ground. They go up and then come back down like that. And the angle will be given, so you can calculate V0x and V0y. V0x there and V0y. And you can calculate the maximum height right there, total time of flight, how much time it takes to get there, and how much horizontal distance you can calculate, x minus x0. So that's the range. And that's one type of problem. So number 8 and also 17 is also similar. So initial velocity at an angle. So you can see that number 18, it's not fully visible, but number 18 looks also the same. A projectile is fired at an angle of 50 degrees above the horizontal. So all of these problems fit with this figure. Okay. The other types of problems are the horizontal velocity. When things start horizontally, like this problem 14, if you draw the trajectory to make it so this is horizontal, and then it has to go just beyond the ledge. So it could have been a little bit longer, but yeah, so that's x minus x0. So you're given x minus x0 and y minus y0, and you need to calculate velocity. But this is horizontal. So the other type that I was going to talk about is just that. So you start at a certain height, and then you project something horizontally, and then you look at the trajectory that it traces. The trajectory looks something like that, and this is x minus x0, and this is y minus y0. Okay, so that's what you can do. The other type, the third type, is you fire something from the ground and then you end up at a higher point, or you fired something from a certain height like this, and then you look at how far it lands. Okay, so that's the third type. So let's focus on the first and second for now. The first problem, problem 8, is actually pretty simple. It says, what are the magnitude and direction relative to horizontal of its instantaneous velocity at the moment it is fired and the moment it reaches its maximum height? So basically we need to look at the horizontal component of the velocity. So if the angle is 60 degrees there, the horizontal component would be V0x, which is V0 cosine of 60 degrees, because that's the adjacent, right? So you get cosine 60 is 1/2. So basically you get 30 meter per second times 1/2, which is 0.5. So you get 15 meter per second. That's your v0x. Now, the moment it is fired, that's the answer. Part B, the moment it reaches maximum height. At maximum height, Vy is 0, but Vx, it's still the same as V0x, because if you look at this equation right there, Vx component of the velocity never changes. So I can write that Vx at maximum height is still 15 meter per second. Okay, so that's all you have in number 8. If you look at 15, we can do 15 also the same way, because 15 fits the same same type as the first one. So let's do 15. Okay, so start with a simple diagram for the projectile. So it's a horizontal line. The projectile is thrown with initial upward velocity, so v0y is 15 meter per second, and v0x, which is the horizontal, is 18 meter per second. So the trajectory is going to look something like this. So it goes up, and eventually it's going to go down and then hit the ground right there. So from here to here, this is called the range, or the horizontal displacement, and the maximum height is somewhere in the middle right there, and that's y minus y0. So this problem asks how much time is required for the football to reach the highest point, which is this point. So we need to calculate the time to go from here to there. Okay, that's what we need to do. So part A, time for max height, t for maximum height. Whenever you have information about the maximum height, always remember one thing: Vy at maximum height is equal to 0. Vx, though, is always equal to v0x, which is here, right there. So Vx does not change because there is no acceleration, but Vy is 0 at the maximum height. Okay? So let's use this information, Vy equal to 0, and try to extract time from one of these y equations. Okay, so again, Vy, when you put Vy equal to 0, so we can select one of these equations. We need to calculate the time, so we have to use an equation that has time, either this one or this one. The second one, we don't know how high it is, so we cannot use this equation. But if you look at the first equation, we know the final velocity, which is 0. We know the initial velocity. The only unknown is t. So you can use the first equation to calculate the time. So let me rewrite that. So Vy equal to v0y minus gt. So Vy is 0. So all I have to write is t equal to v0y divided by g. So that's equal to 15 meter per second divided by g, which is 9.8 meter per second squared. Use your calculator. So 15 divided by 9.8 is going to give you the time, and that's going to be in seconds. Let's look at part B. How high does it get above the release point? So that means that's the maximum height. So in part B, they're asking y minus y0. Y minus y0. So you can use the second equation because you just calculated the t. Okay, but you can also use the third equation, Vy squared minus v0y squared divided by negative 2g. At the maximum height, Vy equal to 0. So you can write that's equal to v0y squared divided by 2g. This negative and negative cancels out. So basically it's 15 squared divided by 19.6 meters. Okay. Now part C says how much time after it is thrown does it take to return to its original height. So we need to calculate time for the entire flight. Because this is a symmetric system, the time would be just twice as much as what you calculated for the maximum height. Okay, so 15 divided by 9.8 times 2. But you can do the quick calculation and see how much time it takes. Okay. But we can use the second equation and calculate the time for the entire trajectory. Okay, so t for the entire trajectory would be from this y information. Y minus y0 for here, for the entire trajectory, y minus y0 is 0 because you have initial point and final point, they are in the same height, so y minus y0 is 0 is equal to v0y v0yt minus 1/2 gt squared. You factor out t, okay, you get t times v0y minus g over 2t equal to 0. So this is going to give you t equal to 0. That's one of the answers. The other time comes from this, and you can write t equal to 2v0y divided by g, and if you look at this, this is twice as much as the time for the maximum height. Now let's do part D. Part D is how far has the football traveled horizontally from its original position. So how far from horizontally means we need to calculate x minus x0. The equation for x minus x0 is on the x side, which is right there. So if we use the time of flight, the total time to go from here to there, then you can calculate x minus x0. So x minus x0 is equal to v0x times t, which is equal to v0x is 18 meter per second times t. I haven't calculated that, so 2 times 15 divided by 9.8, and that's in seconds. So that would be the answer. Whatever you get, just put it there, and that will be your answer. Okay? Let's go back to look at some of the additional problems. Let's say this 16, it has certain angle, has initial velocity, so you can calculate v0x from this and v0y. Because this is above the horizontal, v0x is the adjacent, so cosine of 57. 24 cosine 57 is v0x. 24 sine of 57 is v0y. So if you do that, then it's going to look pretty much the same as 15. Okay, so do this problem. Let me do one that has horizontal velocity. Okay, like this one, for example. So let me do 11 right here, which is similar to number 10 also. A physics book slides off a horizontal tabletop with a speed of 1.1 meter per second. It strikes the floor in 0.35 seconds. Let me quickly set up the problem right here. Right there. And so a table there, and then a book slides off the table with horizontal velocity, 1.1 meter per second. And the trajectory that it traces would look something like that. Okay, and we need to calculate the height of the table, so that means y minus y0. So y minus y0 equal to what? And also x minus x0 equal to what? Okay. Okay, so if you look at the equations in x and y, so if you write the equations there, so these are the equations for x and for y. So for x, we can easily calculate what x minus x0 is by using this equation. Remember, this is horizontal, so this is already v0x. Okay, v0x is 1.1 meter per second. What about v0y in this case? Initial y velocity. Initial y velocity is 0 because it's purely horizontal, so no component in vertical. v0y equal to 0. So now the range, which is x minus x0, actually that's horizontal distance, part B. So part B would be that v0x, which is 1.1 meter per second times t. They gave you the time to strike the floor, so times 0.35 seconds. That's the answer. That's how simple it is. Now y minus y0, just use this right there and you get the answer. So equal to v0y is 0, so you don't need that. So that would be 1/2 g, which is 4.9, t squared, which is 0.35 squared, and that's in meters. So you get a negative sign because y minus y0, the displacement is negative, but the height itself you can convert to positive. So that's the answer. So do as many problems as you can. All right.